Hey everyone, welcome back to Public Health Decoded. So, in our previous video, we have seen what is sampling, why sampling is needed, what are the objectives of sampling, and broadly we have classified the types of sampling. So, in today's video, we will follow up on that and we will see in detail about the types of sampling. With each sampling, we will see in detail, including the principles, merits, demerits, and the example for each of the sampling. Firstly, as we know, there are two types of sampling, probability sampling as well as non-probability sampling. And probability sampling is also known as random sampling, whereas non-probability sampling is known as non-random sampling. So in this video, we will cover all the sampling which comes under probability type of sampling. And in next video, we will see all the types of sampling which comes under the non-probability sampling. So let's get started. So, as we all know, probability sampling is a random sampling, and in this type of sampling, every individual, every unit has a known chance of selection. So, here this selection bias is reduced as well as the results are more generalizable as compared to non probability sampling. In this, we will study seven different types of sampling. First, we will learn about simple random sampling, then coming on to the stratified random sampling. Then we will see systematic sampling, multi-stage sampling, multiphase sampling, cluster sampling, and last is lot quality assurance sampling. So we will see its principle, merits, that is advantages, demerits, disadvantages, and example to understand each sampling. So, starting with simple random sampling. The principle is very straightforward, that is, every unit of population has an equal chance of being selected. Imagine putting everyone's name into a bowl and randomly picking names. No one has an advantage or disadvantage. Everyone has exactly the same probability of being selected. So, the merits of this sampling is it is very easy to perform, especially if population is small and we have all the list frame which we have to take sample from. The merit of this sampling is it is very easy to perform, especially if the population is small and you already have a complete list of individual. Second, because the selection is random, statistical analysis becomes easier and the sample usually represents the population well. Third, everyone has an equal chance of being selected, making the process very fair. The demerits of this sampling is the biggest limitation is that we need complete sampling frame. That means a complete list of everyone in the population. Without that list, we cannot perform simple random sampling. Another limitation is that purely by chance, the selected participants may all come from one part of population. For example, suppose I am selecting students from an entire university. By chance, many selected students could only belong to one department. So, although the selection is random, the sample may sometimes not be well spread across whole population. So, by randomness, the sample may sometimes be localized. It may not be spread across the entire sampling frame. There are two methods through which this sampling is done. One is lottery method, another is table of random number method. For example, we need to randomly select 5 students from a class of 50 to form a study group. So we will first assign number to every student starting from 1 to 50, and then we will create slips from 1 to 50 and put them in bowl and shuffle them well. And then we will draw out one number and note the number. Then I will replace the slip drawn, reshuffle and draw the second one. I have to repeat the process till 5 numbers are drawn. And if the same slips come for the second time, I have to reject that slip. This method is exactly like conducting a lottery, which is why it is also known as lottery method. Coming to table of random number method, this method is used nowadays very commonly. So example is a researcher wants to select 4 participants from a total of 22 participants. Participants are numbered from 1 to 22 and researcher uses a random number table to make selection. This is a random number table. Participants are numbered from 1 to 22 and we will look for 2-digit number from the random number table. As our numbers are from 1 to 22, we will ignore any numbers which are greater than 22, and for single digit number, if we pull number 07, that will correspond to student 7. We will blindly point any numbers and read from left to right in a continuous manner. For example, I have blindly pointed to this number. Now I will start reading from left to right. So first is 11. 11 is between 1 to 22, it gets selected. 81 larger than 22, we will reject it. 43 larger, rejected. 87 larger, rejected. 45 larger, rejected. 71 larger, rejected. 12 is between 1 to 22, so selected. Similarly, in this table, the number 11, 12, 14, 21 are selected. Everyone uses different types of random number table. Now let's move to another very commonly used method called as systematic random sampling. This method is used when we have a complete list of population from which we need to select our sample. Systematic procedure is followed here to choose a sample by taking every kth house or the patient. That's why this is known as systematic random sampling. What is K? K refers to the sampling interval which is calculated by the formula total population divided by sample size desired. Merits of this sampling is sample is spread throughout the population. Sample will cover all the parts of the sampling frame and it will not be localized to the one particular area, and it is relatively simple as well as convenient to adopt. Demerits are it takes more time, cost of data collection is increased, and also for example, every 10th record belongs to the same category. It can introduce something which is known as systematic error, making the sample less representative. One point to note is suppose if the sample which is selected does not give the data, then for example there are household and one household which is selected is logged. So two methods can be adopted. One is next method and second is repeat method. In next method, if it is eighth household which is logged, then I will take ninth one. And repeat method is at last I will take one extra sample. Let's understand this with an example. A researcher wants to estimate the prevalence of hypertension among adults in a village. Total number of adults in the village is 1000 and required sample size is 100. So how we will do systematic random sampling? First we have to prepare the samplings frame. First, I will obtain a complete list of 1000 adults from the village health register and I will number each person in a sequential manner from 1 to 1000. Then I will calculate sampling interval which will be 1000 upon 100 which will come as 10. So my sampling interval is 10. Then I will select a random starting point between 1 and 10 by choosing a random number between 1 and 10. Suppose my random number selected is 7. The seventh person will become my first participant, and the next participant would be 7 plus sampling interval, which is 10, that would be 17. Next would be 17 plus 10, 27. Next would be 27 plus 10, 37, and so on until my 100 participants are selected for the study. Notice something important here. Only the first participant is selected randomly. After that, every selection follows a fixed interval. That's why this method is called as systematic random sampling. In this figure, we can see that every third individual is being selected. Every third individual is being selected. Next comes the stratified random sampling method, which many students initially confuse with cluster sampling. But the principle here is very important. We use stratified sampling when the outcome of the research is dependent on the subgroup. First, here we divide the population into the strata. A stratum is a group where people are similar within the group but different from the people in other groups. Strata is a group which is homogeneous within itself and heterogeneous in between. So, for example, if we are studying religion, we may divide the population into Hindus, Muslim, Christians, and others. If we are studying age, we might divide participants into children, adults, and older adults. After creating these strata, we perform simple random sampling separately within each stratum. The biggest advantage is that every important subgroups gets represented, so this improves the accuracy of the study. There is greater accuracy. Also, group comparison is the purpose of the study. Also, estimates of different characteristics can be made from each stratum separately. However, the limitations are creating strata requires detailed information about the population, making the process more time consuming as well as costly. Let's understand this with a simple example. Suppose a population has 1000 people. Among them, 800 are Hindus, 100 are Christian, 50 Muslim, and 50 other religions. If we want a sample of 100 people among them, we should not simply select 100 people randomly. There is a chance that one religious group may become underrepresented. Instead, we divide the population into four strata. Then we select participants from each group according to their proportion in the population. This ensures that every subgroup is fairly represented. You may also hear the term probability proportional to size or PPS. This means larger groups have higher probability of contributing more participants because they represent a larger proportion of the population. In this example, if I will do proportional sampling, I will select 80 Hindus, 10 Christians, 5 Muslims, and 5 others. Whereas in non proportional sampling, I can select 25 members from each of the strata, but this will be disproportionate. Probability proportional to size is the probability of selecting an item from a population which is directly proportional to the measure of size. As in Hindus, the participants are more, that's why in the sampling, I am taking more samples from the Hindu category. So there are two types of stratified random sampling, which is proportionate stratified sampling and disproportionate stratified sampling. Now let's discuss one of the most important methods in public health, cluster sampling. Cluster sampling is used to study large population, particularly those that are widely geographically distributed. It is used when units of the population are natural groups or clusters such as villages, wards, blocks, school, colleges, etc. So instead of selecting individuals directly, we first divide the population into natural groups, which are called as clusters, and then we randomly select some cluster. The WHO frequently use cluster sampling for evaluating immunization coverage. A famous example is 30 into 7 clusters used by WHO, where 30 clusters are selected and 7 children are examined in each cluster, making a total sample of 210 children. So, the major advantage is it reduces the travel and administrative cost. It is cheap, quick, and easy to do method. The demerits are selected cluster may not perfectly represent the whole population. It can over represent or under represent, so the estimate may be slightly less precise compared to the simple random sampling. Now let's see how it actually works with the example. Suppose a researcher wants to estimate the prevalence of obesity among school going children. Here population is a city has 100 schools and each school has approximately 500 students. So instead of preparing a list of 50,000 students, which will be very difficult, the researcher considers each school as a single cluster. So next, the researcher randomly select 10 schools out of those 100 schools. After selecting these 10 schools, every student studying in those schools is included in the survey. The remaining 90 schools are not included. Since we selected the clusters and included everyone, those who are inside that clusters, means we selected the school and included every individuals that were in that schools. This is called as one stage cluster sampling technique. Remember this point because this is often asked in exams. If all individuals within the selected clusters are studied, this is one stage cluster sampling. Now let's understand two stage cluster sampling. Suppose a district has 50 villages and each village has around 200 adults. Again, each village is considered as a cluster. In the first stage, we randomly select 5 villages. Now, here is the difference. Instead of studying every adult in those villages, we prepare a list of adults only within the selected villages. Then we randomly select 40 adults from each of the village. So our total sample becomes 5 villages multiplied by 40 adults, which is equals to 200 adults. So I have selected 40 adults from each village. So in stage 1 we first selected the cluster. In stage 2 we selected individuals within those clusters. That is why this is called as two stage cluster sampling. A simple trick to remember is if everyone inside the selected cluster is included, it is one stage. If you again sample individual inside that cluster, that becomes two stage cluster sampling technique. So now moving on to multi-stage sampling. Many students confuse cluster sampling with this multi-stage sampling. Although they look similar, there is a very important difference, which is in multi-stage sampling, sampling happens in a multiple successive stages. For example, first there are states. In states, we have selected some cities. Then in the cities, we have selected some towns. And then in that towns, we have selected some households. So we are moving from each unit and each unit is nested in the previous unit. This type of sampling is employed mainly in the large country surveys. because it becomes impossible to prepare one complete sampling frame for the whole country. So now let's look at its advantages. Since we use existing administrative division like states, districts, blocks, villages, it saves time and effort. Also, we don't need a complete list of entire population, that is, no need of sampling frame of the entire sampling universe. However, because sampling happens at several stages, the sampling error is usually higher than that of the simple random sampling, and the sampling units may vary in size at different stages. So now let's understand this with one public health example. Suppose we want to estimate the prevalence of anemia among school going children in Karnataka. Now imagine trying to prepare a list of every school child in Karnataka. Obviously, that would be so difficult. So instead of dividing sampling into stages, first we randomly select few districts in the Karnataka. Then from that district, we randomly select some of the blocks. Then from each block, we randomly select school. From each school, we randomly select classes. And from each class, we are randomly selecting students. So this is a 5 stage sampling design. Notice that sampling is happening repeatedly. Districts, then blocks, then schools, then classes, and then students. So, since sampling occurs at multiple levels, this is called as multi-stage sampling. One easy way to remember is cluster sampling usually involves one or two stages, whereas multi-stage sampling involves three or more than three stages. Three or more than three stages. Next comes another interesting method which is known as multiphase sampling. Please don't confuse this multi-stage sampling with multiphase sampling. In multi-stage sampling, we change the sampling units. But in multi-phase sampling, we keep on studying the same sample in different phases while collecting different information. Initially, information is collected from everyone. Then, based on the findings, only a subgroup proceed to the next stage. Finally, a even smaller subgroup enters the last phase. So the sample size becomes smaller with each phase. So the advantages of this technique is it saves money and resources because expensive investigations are performed only on the selected participants. So it is less costly, less laborious, and more powerful. However, it is a complex method and it usually takes more time. So let's understand this with an example. Suppose researchers wants to study tuberculosis, people suffering from tuberculosis. In the first phase, everyone undergoes Montauk's test. Now, only those who test positive move to the second phase where a chest x ray is performed. Again, only those whose chest x ray appears suspicious proceed to the third phase where a sputum examination is conducted. So, every participant does not undergo every investigation. More expensive investigations are reserved only for those who need them. That's exactly why this method is known as multi-phase sampling, as we are proceeding from one phase to the other. Now let's move to the lot quality assurance sampling, commonly called as LQAS. This sampling method was originally developed for industries for the product quality checking, mainly for industries for the product quality checking. Later, it became widely used in public health to monitor public health programs. Here, the principle is very simple. The population is divided into lots, and the small random sample is selected from each lot. Each lot is classified as acceptable or unacceptable based on whether the number of defective cases is below or above a predetermined decision value, that is cutoff. So the population here is divided into lots. A lot could be a factory batch, a district, or even a primary health center. Then we compare the number of defective or poor performing cases against a predetermined cutoff value. If the number remains below the cutoff, the lot is considered acceptable, and if it exceeds beyond the cutoff, the lot is classified as unacceptable. The major advantage is it requires a small sample size, making it as quick as well as cost effective. Also identifies poorly performing areas, lots, so that targeted intervention and efficient resource allocation can be done. Remember one limitation here: LQAS is not designed to estimate the exact prevalence estimates for the entire population. Its purpose is to only classify whether lot is performing well or poorly. So let's first understand the original industry example. Suppose a mobile phone factory manufactures 1,000 chargers in one production batch, which is a lot, and the quality inspector randomly selects 50 chargers for inspection. The factory has already decided that maximum of 2 defective chargers is acceptable. If the inspector finds only 1 or 2 defective chargers, the entire batch is accepted. But if 3 or more are defective, the manager will reject the entire lot or send it for reinspection. So, notice something important here: the inspector is not calculating the exact percentage of the defective chargers, but the only decision is whether to accept or to reject the lot. That is the essence of lot quality assurance sampling. Now let's see how LQAS is used in public health. Suppose a district has 15 PHCs. PHCs will be a lots, and from each PHC 19 children are randomly selected to check immunization status. If more than 3 children are not fully immunized, that PHC will be classified as poorly performing PHC, and those PHC will receive additional supervision, training, and corrective action. So, again, notice the purpose here is to not calculate the immunization coverage, but the purpose here is to identify which PHC needs improvement. So that's why LQS is mainly a quality monitoring tool. So now many students confuse cluster sampling with lot quality assurance sampling because both divide the population into groups, but their purposes are completely different. In cluster sampling, our goal is to estimate something for the entire population. For example, what is the prevalence of hypertension in this district? Here we select some clusters and estimate prevalence. On the other hand, lot quality assurance sampling, our goal is not estimation. Instead, we ask which PHCs are performing poorly. Here, every PHC is treated as one lot. We take a small sample from each PHC and classify it as either acceptable and unacceptable. Now we have completed all the major probability sampling techniques, including cluster sampling, multi-stage sampling, multiphase sampling, simple random sampling, lot quality assurance sampling, and various other techniques. So in the next part we will begin non-probability sampling, where we will discuss convenience sampling, purposive sampling, snowball sampling, and quota sampling with simple examples. Thank you so much for watching this part of video. If you found this explanation helpful, don't forget to like the video, subscribe to the channel, and share it with your friends who are preparing for MPH, community medicine, nursing, or any research related examination. See you in next part where we will see non probability sampling methods. Thank you.